Hello everyone, I am Shovi. Today we will discuss about the conformational analysis of cyclohexane. As we know that the cyclohexane is a cyclic compound. So here we discuss about the conformations of the cyclohexane. Uh, Cyclohexane has the four types of conformation. Number one is chair conformation, number two boat conformation, number three twist boat conformation, number four half chair conformation. So first we talk about the chair conformation. Here if we numbering the carbons here, so first we numbering the carbons in the chair conformation. Here we you will see that this conformation is like the chair like structure. So this this is you can say that this is a carbon, this is a carbon, this is a carbon, so we can numbering the carbons as well. So numbering the carbons, and this is the number 1 carbon, this is the number 2 carbon, this is number 3 carbon, this is number 4 carbon, and this is number 5 carbon, and this is number 6 carbon. So here we see that there will be 6 number of carbons. So here in this conformation there will be two types of hydrogens are present. One is axial carbon and another is equatorial carbon, equatorial hydrogen. Sorry, this is a equatorial. This is a equatorial hydrogen, and this is a axial hydrogen. Equatorial hydrogen is present in a equatorial plane, and axial hydrogen is present in the axial plane. The in this case the two hydrogens are present in the different planes. You can see that this hydrogen is also in the equatorial plane, and this hydrogen is also in the axial plane, and this hydrogen in this carbon particularly, this hydrogen is axial plane, and this hydrogen is in the equatorial plane. Next we will see the Newman projection of the cyclohexane of the chair conformation. So first we sketch the Newman projection of the chair conformation. So let's go. First we sketch the chair conformation. This is a chair conformation. So now this is a this is an axial carbon, axial hydrogen. This is a equatorial hydrogen. This is a axial hydrogen. This is a equatorial hydrogen. This is a axial hydrogen, and in this carbon this is a axial hydrogen, and this is a equatorial hydrogen. And this is a axial hydrogen. So in this case we will we will consider the two rotation in this structure. So you can say, you can let two rotation in this conformation to derive the Newman projection. So here we consider this rotation. Oh, sorry. Here we rotation. Here let's say here we consider the rotation between this carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 and carbon 6. So here we consider the two rotation, that is the rotation 1 is rotation between the carbon 1 and carbon 6. One is rotation between the carbon 1 and carbon 6, and another is rotation between the carbon 3 and carbon 4. So now, so for two rotation, we will get the two. So we will sketch the two circles for the Newman projection, because for any acyclic compound, if we consider in that case, we will consider the only one rotation, that is why there will be only one circle is present in the structure. So let's sketch that circle. So I will import the circle as import the two circles here. Now, so this is this is the Newman projection. This is one Newman projection and this is two Newman projection. So for the first Newman projection, this is 3 and 4. We consider the Newman projection first. We will consider the Newman projection between the carbon 3 and carbon 4. So here you can see that, and this hydrogen and this axial hydrogen and this axial hydrogen are two anti to each other, and this axial in equatorial hydrogen and these equatorial hydrogens are anti to each other. So here we if we sketch the Newman projection for the rotation of this C3 and C4 carbon. So here we get that this is, if we consider this, that this is C3 carbon. Sorry. If we consider this is the C3 carbon, that is this is this carbon. So here we see that the hydrogen is at this point, and this carbon and this hydrogen at this this axial hydrogen is this axial hydrogen, and here we see that this equatorial hydrogen is in this side. And as we previously we will see that the these axial hydrogens are anti to each other. So here we These hydrogen and these two hydrogen and these two hydrogens um, are at the anti to each other in the Newman projection. So here we sketch that two hydrogen, that is this hydrogen, this is the hydrogen, this hydrogen is this axial hydrogen is this axial hydrogen, and this equatorial hydrogen we will uh, the, these axial this equatorial hydrogen is in that position, in this position. So so in this is a 4 C4 carbon. Now uh, so this is now this is the CH2 for for C3 carbon. This is the CH2, this is C2 carbon. And this C2 carbon is connects to the C1 carbon. So this is C1, this is the C1. So this directly connects to the C2 carbon, is directly connects to the C1 carbon. And for this C1 carbon, for this C1 carbon, we here will be hydrogen. Sorry. This axial hydrogen is this axial hydrogen in this position, and these two axial hydrogens are anti to each other. So for this for this this axial hydrogen is at this position CH, and this equatorial hydrogen is at this position, and these equatorial hydrogens is at this position. Sorry. And opposite so this C1 the opposite carbon of this C1 carbon is C6, and this and here we see that C4 C5 carbon is connects to the C6 as well as C4. So here is sketch that. This is the C5 carbon. You can see that here all the hydrogens are in the staggered position. That is, this hydrogen is at the staggered position. All the bonds are at the staggered position. So there will be no torsional strain is present in this conformation, as well as here the all hydrogens or all the bonds are in the staggered position. So here also when there will be no torsional strain is present in the in this chair conformation. So this is so there is in case of the shear conformation, there will be no torsional strain is present, as well as there is no steric strain is present. So now we will talk about the boot conformation. In the boot conformation, there will be in the this is the boot conformation of the cyclohexane. This is the carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 and carbon 6, and this is in this case this is a axial hydrogen, this is a equatorial hydrogen, and this is a equatorial hydrogen, and this is an axial hydrogen. And for this carbon, this is a equatorial hydrogen, and this is a axial hydrogen. And for this carbon, this is a equatorial hydrogen, and this is an axial hydrogen. Now we will first consider about the Newman projection of the boot conformation. And like the shear conformation of the cyclohexane, we like the shear conformation of the cyclohexane. Here also we will consider about the two rotation in this boot conformation. So first we will sketch about the boot conformation. So this is for this carbon, this is a axial hydrogen. For this carbon, this is a equatorial hydrogen. For this carbon, this is a equatorial hydrogen, and this is a axial hydrogen. For this carbon, this is a axial hydrogen, and this is a equatorial hydrogen. For this carbon, this is a axial hydrogen, and this is a equatorial hydrogen. First, we will numbering the carbons here. That is, this carbon. We will numbering this as 1. This carbon as number 2. This is 3. this carbon as number 4, this is number 5, and this is number 6. Here also we will consider the rotation upon the rotation. Here also we will consider the two rotations. One is around the C1 and C2, and other is around the C3 and C4. So here we for the two rotation, here we get the two here we sketch the two circles, that is the two Newman projection for it. So here we will import the two circles here for Newman for sketching the Newman projection. So first here you will see that these hydrogens and this hydrogen, this equatorial hydrogen and this equatorial hydrogen is in the same site, that is for if we consider the first C1 carbon, then this hydrogen which is associated with the C1 carbon is at this. Here will be here will be the equatorial hydrogen. And here, and this hydrogen, this axial hydrogen is at this point. This is the C1 carbon, and this carbon C1 carbon is associated with the C6 carbon. That is, this is C6 carbon. Oh, sorry. This is C1 carbon. So and this hydrogen, that is now we will consider the C2 carbon. So here opposite to that to this C1 carbon of the circle, there will be C2 carbon there, because we will consider the rotation about the C1 and C2 carbon. So this axial hydrogen is at this position of the C2 carbon, and this equatorial carbon and this equatorial hydrogen is at this position of the C1 carbon. And this C2 carbon is connected to the C3 carbon, and this now we consider the rotation about the C3 and C4 carbons. So here also we get the hydrogen is at this position for the C3, This is the carbon C3. And opposite that carbon there will be another carbon which is C4. For the C3 carbon, this axial hydrogen is at this position, and this C3 carbon is connected to this C6, and this equatorial hydrogen is at this position, this carbon is C6, and this carbon is C5. For the in case of the C4 carbon, the this axial hydrogen is eclipsed to this C3, this hydrogen, and this equatorial hydrogen is eclipsed to this C3 hydrogen. So you can say that all the bonds are eclipsed to each other. So as we know that for the eclipse conformation, for any structure there will be torsional strain is maximum. So in the boat conformation there will be so much amount of the torsional strain is present in the structure. So this is unstable than the shear conformation. And here and in the boat conformation there will be another strain is present, which is the steric strain. That is, you can see that this these two flagpole hydrogens, that is this and this, these two flagpole hydrogens are so close to each other, so there will be some steric strain is present in that conformation. So this is so we can say that shear conformation is more unstable. Boat conformation is more unstable than the shear conformation. So its energy is greater than the shear conformation. So now we will talk about the twist put conformation. In the case of the twist put conformation, here you will see that two two flag pole here. Here two flag pole hydrogens are too much distant to each other, that is there will be no steric strain is present in that twist conformation. So we can say that the twist conformation is stable than the boat conformation. Now we will analyze the conformations of the cyclohexane. So here we will say that the chair conformation is the most stable conformation of the cyclohexane. Then this uh, twist boat conformation, and then the boat conformation, then half chair conformation. So the stability of the conformations of the cyclohexane will be decreases from cyclo decreases from chair conformation to the half chair conformation, and the energy increases from the chair conformation to the half chair conformation. So here you can see that if we will plot the energy in the y-axis, so we will get the minimum energy which is present in the chair conformation, and twist boat is at the higher energy level than the chair conformation, and boat conformation is at the higher energy level than that of the twist boat conformation, and half chair conformation is very unstable conformation. So in many cyclohexane compound, the chair conformation is the most stable compound than any other conformation. So we will say that the chair conformation is present in the more percentage than the other conformations like boat conformation and the twist boat conformation. So now this is for today.